ماما ماما اس أنا راح ندخل بودكاست في صوت مقاوم بعد ما يمكن تحبي تدي دوار واحد يطبط به عليا نمدهولك وطرش. السلام عليكم. تشوفوا تسمعوا في الصوت مليح وتجيكم الصورة. الو So last time we arrived at we solved exercise 1. I will send you right now I will share with you right now in the classroom series number 2 of exercises, so you will have all the complete exercises. While you watch, you will have the series and you can see the exercises. Just wait a little bit. So okay, this is the series. Series number 2 of the is now you can download the series number 2 of exercises and follow with me the exercise number 1. So last time we arrived to the solution of the equation. So yes, the equation y prime is equal to exponential y minus x over cos y multiplied by 1 plus x squared, which is the third case of exercise number 3. Now we move to equation number 4. So equation equation number 4, which is y prime over x is equal to check the classroom, you will find the exercise, the series of exercises is equal to sine y over the square root of 4 minus x to the power 4. So this is the equation that we will solve right now. First, we need to prove that this equation is separable. We need to show that this equation is separable. So, can I continue? Do you hear my voice clearly and you see the image very clear? نقدر نكمل، ما كان حتى مشكل في الصوت ولا في الصورة. So, let's continue. So, this, when we write this part is, you could rewrite it like this. It is 1 over x times dy over dx. Okay, and this part is sine y over the square root of 4 minus x to the power 4. Now, I will multiply by dx and divide by sine y. So this part will become like this. It is dy over this guy. So I multiply like the I will multiply by dx and the square root of 4. Sorry, let's first multiply only by x dx. So we will find here this is equal to x dx, and I will divide by sine y, and this is sine of y. Okay, all over the square root of 4 minus x to the power 4. Now it is clear that this part depends only on x, and this part depends only on y. Sorry, someone wants to enter. Yes. So we continue. So as you see, this type is a separable differential equation, and this is the separated equation. So now we will integrate both sides with respect. So now by integration we integrate those two parts. So the integral of dy over sine y is equal to the integral of x dx over the square root of 4 minus x to the power 4 plus some constant c. As you can see here, just wait a little bit. Yes. to compute this type of integral, we have it is not of the type y prime over y. So here we need to make a change of variable so that the sine y will become a polynomial of some other variable that we could and that we can integrate later. So we will use a change of variable. Sorry. So now we do a change of variable, computing the integral of dy over sine y. So we put a variable z is equal to tangent y over 2. Now using this rule that you may see here, this is the angle y, and by this new change of variable we could find that this part of the triangle is equal to 1 minus z squared, and this part is 2z, as we have seen this in classroom, and this part is 1 plus z squared. And by the triangular relationship between the sine and cosine, you might see that sine of y is equal to this part over this part. So it is equal to 1 minus z, sorry, this part, it is 2z it is 2z over 1 plus z squared, and also since z is equal to tangent y over 2, y here is equal to 2 times arc tangent z. So when you take the derivative of so dy will equal to 2 over the derivative of arc tangent z is 1 plus z squared, and all of this times dz. Now we substitute in our integral. So the integral of dy over sine y, now with this new change of variables, is equal to yes, so the integral of 1 over, between parentheses here, 2z over 1 plus z squared times dy is equal to 2 over 1 plus z squared times dz. Now you simplify. This 1 plus 2z goes with this 1, and this 2 goes with this 2. What remains is the integral of, what remains is only z here. So it is 1 over z times dz. And this is simply equal to ln z. Now you return back to our variable. Remember that z is equal to tangent y over 2. So this is equal to ln tangent of, tangent y over 2. Okay. Now you integrate this part of integral of the equation. We finished with this part. What remains is the integral of x over the square root of here. So x over the square root of 4 minus x to the power 4. To do this integral, we must do a change of variables. So, as you may see, let's put, this is actually, you can rewrite it to this form. So you divide and multiply by 2, it becomes like this. 4 minus x, and this x to the power 4, you might write it x to the power 2 all to the power 2 times dx. Now this is actually equal to 1 over 2, and remember that 2x dx is actually the derivative of x squared over the square root of 1 minus x squared all squared. Now it is very clear what change of variable we must do. So put u is equal simply to x to the power 2. This means that the differential of u over dx is equal to 2x. And this follows that du actually is equal to 2x times dx. So we substitute here, which is simply this part. So this is equal to du, and this x squared is equal to u. So this actually is equal to 1 over 2 the integral of du over the square root of 4 minus u squared, and this 4 actually is equal to 2 to the power 2. So what is the antiderivative of this one? This is a known form that you know it's integral. What is the integral of this part? Anyone knows the integral of the integral of du over the square root of 2 to the power 2 minus u squared? Just to remind you, this is of the form the integral over dx of the square root of a squared minus x squared. See the table of integration in the course. For those who assist the lectures, see the table of integration, you will find this. So I will give you the solution. The integration of this is simply equals to it is equal to 1 over a arc sine x over a. Check if I did a mistake. I may make mistake. I am not sure if there is 1 over a here. So let me check. So sorry.
بس كاينة 1 over A.
وش كاين؟
صحيحة هكذاك.
صحيحة هكذاك. Très bien. So we continue. So this here a is equal to 2, and here x is u, so, and we have 1 over 2, so this becomes 1 over 2 arc sine of u over a, which is here 2. Okay, uh, so is this correct till now? Okay, Rayla, you may, if you have a suggestion, you may talk. Yes, you said that there is no 1 over a here. Yes, thank you. So just to remind you that the derivative of arcsine arcsine of x is equal to 1 over the square root of 1 minus x squared. Okay, so if we have the integer, if you have something like this, it is 2 squared minus u squared, and you have its integration. You may take gets factor the 2 out. It becomes like this: 1 over 2, the integral of 1 over the square root of 1 minus u over 2 all squared du. Okay, but here when integrating these two, we can bring it here, so this will become the derivative, the integral of 1 plus u over 2 all squared d u over 2. Okay, and this is exactly this form, so its antiderivative is arc sine u over 2. So there is actually no 1 over 2, so this is not correct. So this guy will gives out, so you might delete this part. What remains is only 1 over 2 arc sine u over 2. Now we get back to our solution, so I may delete this, we don't need it. All of this is simply draft. So sorry, just a little bit. So now we continue. So this is arc sine, and what is u? U we took u here is x to the power 2. So this is x to the power 2 over 2. Now we return back to our equation. So this is the equation. I will copy it. Sorry. Copy. So here. So now we replace this part. So and this part. So the integral of du over sine u is actually what is equal to, it is ln tangent u over 2. It is ln, so this part is ln tangent u over 2, and this part is 1 over 2 arc sine x squared over 2 plus some constant c. Now you could multiply by 2, and so this is equal to, here it is 2 ln tangent y over 2 minus c equals arc sine x squared over 2. Now you take the sine from both sides, so this becomes sine 2 ln tangent u over 2 minus c, is equal to x squared over 2. Or so if you let it like this or like this, it is both considered correct. So this is the general integral of our differential equation. Okay? Is there any questions till now? Is there any questions? So I will continue to the next one. Now we go to exercise number 2. Since there is no questions, I will continue to exercise number 2. You can download the series of exercises I just uploaded in the classroom. So exercise number 2. Homogeneous differential equations. So now we pass to homogeneous. Sorry, this is not good. So we change the color to, no, let it like this. So now we pass to homogeneous differential equations. Just to remind you of how we solve differential equations, homogeneous differential equations. An homogeneous differential equation is an equation of this form. It is dy over dx equal to some function of x and y. But this function is homogeneous. What this means that f of lambda x, lambda y is actually equals to equals to f of x and y. That is, it is homogeneous of degree 0. Now when you substitute the lambda with 1 over x, you will get that f of xy is actually equals to f of 1 y over x, and you could consider this as a function of y over x. Okay, so we have in reality a function of y over x. What you do is to consider a new change of variables, which is you put u is equal to y over x, and this implies that y is equal to x times u and when you differentiate y, you will get u plus x times u prime, or which is equivalent to dy over dx is equal to u plus x du over dx. When you substitute this in here, you will get something like this: u plus x du over du over dx is equal to f, big F, I talk about this, big F of u. And now this becomes a separable, separated differential equation. How to do this? You take this u to the other part and divide by u. So this du over dx, it is equal to big F of u minus u. Now you multiply and divide, take the x's to the right and the u's to the left. What you get is du over f of u minus u is equal to dx over x, and this is depends only on x, and this part depends only on u. So this is actually separated differential equation, and you solve it like we did with those of exercise number 1. Now, is there any questions till now? This is just a reminder to you about homogeneous differential equations. So now I will solve exercise number 2. So here we have exercise number 2, and we have problem 1. Problem 1 says you have so problem 1, y prime